piecewise functions.
All right, good afternoon. Today we are looking at piecewise functions, and we want to be able to evaluate. The root of the word is value, and that means you want to find a value, a number answer, okay? And also we want to be able to graph piecewise functions. And so a piecewise function is a function made up of two or more functions. Two or more functions, each with their own domain. Each with, I'm going to say, its own domain. So made up of two or more functions, each with their own domain. And this is, we see overall here, they are functions. And in order for it to be a function, it must pass the vertical line test, okay? So it is important because they are functions that they pass the vertical line test. It's a good way to double check your graph and make sure your graph is correct, and that it should be a function when we're done. When we're graphing today, it's going to be real handy to have a pencil, not a pen, or something erasable, because we're going to do a little bit of erasing as we go here. Okay, so number one, evaluating piecewise functions. We want to find each value given the piecewise function. So here we have a lovely function f of x, and it has three different parts. So we have this first top equation I'm going to do in red. It has this second equation in the middle, and it has a third equation in pink, that third equation. So it has three different parts, three different pieces, but we only use the red piece if I have x values less than -3. Okay, that's a good if question. If x is less than 3, then I'm going to use the red line. Here on the green equation, we're going to use the green if our x value is greater than or equal to -3, but less than 7. So, though that is an if statement, so we want to see where does our x value fit. So here on letter A, what is my x value that I'm going to plug in here? -5. So this is saying x equals -5, and we want to plug it in, and we want to figure out the corresponding function value, the corresponding y value. All right, our x value is -5. Should it go in the top, the middle, or the bottom? The top, yeah. -5 is less than -3, so that is where it fits. That's the true statement. And so we're going to plug it into the top equation here. So I'm going to take my red equation, and I'm plugging in -5 in place of the x. So what is -5 minus 5? -10. So I have 2 times the absolute value of -10. What is the absolute value of -10? 10. And times by 2, we get 20. So f of -5 equals 20. Again, what's kind of nice is this is an ordered pair. This is why we like function notation, because it gives us an ordered pair on this graph. -5, 20 is totally an ordered pair. All right, number B. What's our x value? 2. Should that go in the top, middle, or bottom? Middle. So that's x equals 2, and that works right here. 2 is less than 7, and 2 is also greater than or equal to -3. So that's where that fits. That's the true statement. And so we're going to plug it in to our green equation. So negative in place of x, what are we plugging in? 2. In place of x, we're plugging in 2's. All right. Here we have the exponent. What is 2 squared? 4 with a negative. -4 plus 8, and we get 4, yeah. F of 2 equals 4. Good, good. On letter C, what is our x value here? 7. X equals 7. So where do we plug it in? The bottom. Very good, because it is 7 is greater than or equal to 7, so that makes perfect sense there. That is a true statement. So now we plug in our 7 for the x there. All right, we get the square root of 14 plus 6 is 20, and that's a perfect answer. Maybe I would want to simplify that. Let's do that just to remember. Square root of 20, we're looking for perfect squares. 4 times 5, so what is the square root of 4? 2, so we get 2 radical 5. The square root of 4 is 2, so a 2 gets to escape. Okay, a little refresher there. All right, questions on that? No? All righty. I really just want to do letter C here, I think. All right, on number 2 here, again, I have piecewise functions. What function is this one? The little step one, yep, the ladder stair step one. Greatest integer function, which is a little bit weird. So here, our x is 3.1. So does it go to the top, the middle, or the bottom? Bottom one, right here, because 3.1 is greater than -2, so that is a true statement. So we have the greatest integer of 3.1 minus 4. I clean that up. What is 3.1 minus 4? -0.9. Okay. Now, the greatest integer function is maybe pretty weird. What do you think the answer is?
3.
Well, we're here at -0.9. So the integer is the number in front of the decimal here, to the left of the decimal. It looks like a 0, but we're in negative land. It's really kind of weird. It's -1. Okay, so maybe we want to be sure here. If I type in the greatest integer function so you can see here what's going on, I can go to the math menu, arrow over to num, choose my greatest integer function, and I'm going to type this in, x minus 4, just so we can see what it looks like here. Under math, and then num, it's just int. Number 5, yep. All right, so here's my greatest integer function, and if I plug in, I can use trace, and the number that we were plugging in for x was 3.1. So I'm just going to hit that there, and we see right here we get -1. Oh, so that is because I put in x minus 4. I put in the actual function.
Okay.
There you go. So I put in the actual function portion. Yeah. I could do it if I just wanted to use that. I could go back to my home screen and do math, num, integer, and then just put in my -0.9 if I wanted to do that. And you'll see we get -1. So it's the greatest integer function is it's the integer less than or equal to your value. And it's weird when you're in negative land because the number less than -0.9, the integer less than that is -1. All right, the one that's lower. So it's kind of a weird one. So just wanted you to see that. So you can do it in a couple different ways if you wanted to be sure. All right, questions on that? Okay, so now we're graphing. Graphing piecewise functions, I really love this skill in Delta Math. The way they have done it, I think, is fantastic. So I'm going to do it pretty much the same way you're going to see it work in Delta Math. You're going to need to write lightly first, and we're going to erase, okay? Like, we're going to get rid of some stuff. So what we have here is I have two functions. I'm going to have my top one in pink and my bottom one I'm going to do in blue. And I can erase my pen, so this is going to work very good. What we want to do is we want to graph these functions. And that's where we're going to start. So first, I'm going to graph this function. Tell me about this graph in pink here. What shape is it? It's a V. Very good. Tell me more about the V shape. I should be in pink, not blue. Left 3, down 1, right? Left 3, down 1. All right, so we have some shifts here. So if I take my little, I'm going to just do 3 dots for my basic parent function, and I'm going to go ahead and shift those. Left 3 and down 1. So there I am. Here is my little V shape. Right there, I shifted it left 3 and down 1. Now, that function, if I were to lightly draw it in, would be something like this. And it goes on forever and ever. And so Delta Math lets you draw that really beautiful function, but we only want to see this function for x values less than 0. Do I want to see over here when x is 1? Over when x is 2? No, we do not want to see this side of the graph. So I only want to graph this pink graph where my x values are less than 0. So that is the left-hand side of our y-axis here. So I have this side of the graph is all that I care about, the left side. And so in Delta Math, what you're going to do is you get to shrink in the little arrows, and it's going to shrink this side of the graph and make it disappear for you, which is kind of cool. And so that you'll shrink in a side, and half the graph will disappear, which is pretty neat. Now, when x is 0, right here, should I use an open or closed dot? Open dot. Open dot right there. Because it is just less than, not a solid dot. Okay. So then I want to graph 2x minus 5. This is a linear function. Y equals mx plus b. Graphing lines. Where do we begin graphing a line? Negative 5. B is for begin here. B is for begin. Begin at negative 5. 1, 2, 3, 4, 5. On the y-axis, so I'm going to make my beginning point there at negative 5. And then what's my slope? 2 over 1. Yeah, that tells me to go up 2 and right 1. So we graph from my beginning point, I'm going to count up 2, right 1, put a dot. Up 2, right 1, put a dot. Up 2, right 1, put a dot. Up 2, right 1. So here I got this beautiful line going on forever in both directions. So this line goes forever in both directions. But again, I only want to see this graph for x values bigger than 0. So do I want to see the blue graph for when x is negative 1? Negative 2, negative 3? No. So we want to get rid of the left side of this blue graph. So again, I'm going to shrink up this side, erase it until I get to 0. It goes away. Now at x is 0, should I have a solid or open dot? Solid dot. Solid dot because of the equal sign. We got to use a solid dot since it's got the little equals with it. And then I'm going to go ahead and see the right-hand side of my graph there. Get this beautiful graph. Does that make sense to you? Okay. Let's try a couple more.
I wish I had like 2 months ago, Miss G. I wish we went over this early.
Let's do number 6. Let's do number 6. All right, on number 6, I have 3 different pieces that I'm going to graph. And so I have a nice line here. Again, that is a y equals mx plus b straight line function. little diagonal line. I have just a constant function. What shape is that? What does that look like? It's just a straight horizontal line. If you think about it, y equals -1 is exactly the same as y equals 0x minus 1. It is a linear function, but the slope is 0. It goes up nothing and over 1, and up nothing and over 1, and up nothing and over 1.
Since -1 is in between those two, we just draw a straight line at -1.
That's it. Yep. All right, and then I have in my pink graph here, what shape is this graph? Parabola, squaring function. So this is our parabola function. Okay, so we're going to graph these. 3x plus 8. Where do I begin graphing my line? 3x plus 8. Positive 8. 1, 2, 3, 4, 5, 6, 7, 8. It's right there. And then it has a slope of 3 over 1, which means I'm going to grow up 3, 1, 2, 3 over 1. I'm off my graph, so I'm going to go in reverse. I'm going to go down 3, left 1, down 3, left 1, down 3, left 1, forever and ever. Okay, there we go. So here's my big long line, but I only want to see this line for x values that are less than -4. Well, here we go. 1, 2, 3, -4. -4 is right here. So I only want to see this line for -4 and to the right of that or to the left of -4? Left, yeah. So from -4, where I'm intersecting when x is -4, and to the left of that. So just that side of the line there. Yeah. So everything to the right of -4, I got to bring it back in. I got to erase that to get rid of that right-hand side of -4. So all that disappears on us. Does that make sense to you? You good? You got it? Good, good, good. All right. Now, here we have this blue line. Again, you can think about it as y equals 0x minus 1. So again, it has a beginning point at -1, and the slope is 0. What does a 0 slope look like? Straight horizontal. 0 beats per minute. Flat line. That's what that is, okay? It's a flat line. When you got 0 beats per minute, you'd be dead. Okay? So we have a flat line here at -1, and but I don't want to see all of it. Where do I want to see our flat line?
Between -4 and +2.
Between -4 and +2, we are going to see our flat line. At -4, should it be an open or a closed dot? Open dot here. So big open dot. I'm going to erase everything to the left of -4. And then at 2, should we have an open or closed dot? Closed dot. Very good, because it's equal to. So we would use a solid dot on that side, an open dot on the left side there. And I'm connecting my line between those 2 points. Sorry, my open circle does not look very open. There we go. Okay. Okay, good so far? All right. And then the last one, we have a parabola. How is our parabola being shifted? Right to down 5. So I'm going to take my 0, 0, and I'm going to go right to down 1, 2, 3, 4, 5. So here I am. That's the vertex of my parabola. I'm going over, up and over on either side. So there's my parabola shape, but I don't want to see all of it. What side do I want to see? I want to.
Stuff that's greater than 2.
This x is greater than 2. So like 2.1 and 2.2 and 2.3. I want everything to the right, but I don't want this side to the left of 2. Okay? And then at 2, should we have an open or closed dot? Open circle there. So I have an open circle right there at my vertex point there. What kind of discontinuities do we have on this graph? Jump, yeah? We've got jump, discontinuity, jump. I can spell. Jump. Jump discontinuities at X equals 2 and -4. Very good. Jump discontinuities at 2 and 4. Beautiful. Do you have any questions for me? Is that all you want it to be? Is that good? We can do one more if you want to. You're good? Okay. All right. Fantastic.